Okay, today's lesson is to understand how to use GCF, or greatest common factor. Write this down along with today's date and page number before we move on. All right, here's your warm-up. 4 numbers. Write the prime factorization of each. So use your little factor tree, and I'll even do one with you. 14, what are 2 factors that make 14? Did I hear you say 7 and 2? That is correct. Now, if it's prime, circle it. Hey, Mr. Singer, 7 and 2 are both prime. So its prime factorization is 2 times 7. That is correct. You're done with 1. Now you have to do 2, 3, and 4. Come back when you're done, Ski. And here are the results you should have had for each. I guess I can circle them. 1 was 2 times 7. 2 is 2 times 3 squared, or 2 times 3 times 3. 3 was 3 squared times 7, or 3 times 3 times 7. And for number 4, it was 2 times 3 to the power of 3, or 3 cubed, or 2 times 3 times 3 times 3. I hope you got all those right. Remember, it means you remembered what we did the last lesson. Now that your brains are warmed up, let's move on. All right, one of the things we need to learn about is GCF, or greatest common factor. So factors that are shared by 2 or more whole numbers are called common factors. Like 3 and 6 are common factors, right, of 12, because 3 goes into 12 and 6 goes into 12, but they also can go into a different number. Now, the largest of those common factors we call the greatest common factor. So between 2 numbers, there's one number that is the largest that can be multiplied into or can be divided into one of those other numbers. So that's what we're going to try to work on today. Greatest common factor is really important if we're trying to simplify fractions or find equivalent fractions, and that's why I want to do this now before we get into our fraction unit so we can get some practice with this. So, greatest common factor. Well, we just practiced playing the factor game, and you kind of know the rules of finding out these numbers, at least 24. So, to find the greatest common factor, like you see here, what do you notice about all the numbers next to 24, next to 36? You probably recognize that all of them are factors of those numbers. And if you start to go through it, they have several common factors. They both have a 1, they both have a 2, they both have a 3, they both have a 4, they both have a 6, and then 24, 8 goes into 24, but 9 doesn't, but 9 goes into 36, and then they both have a 12. 24 also has 24, and 36 has 18 and 36. But as common factors, the greatest of them is 12. So what we can say is the greatest common factor of 24 and 36 is 12. So the largest number they share in common is 12. It's good to know that stuff. So have this written down before moving on so you can have a good example. And when we get into example 1, we're going to show you different methods. I kind of narrowed them down for you so that it doesn't get too confusing as we move forward. But I want to give you some variety on how you can solve these. All right, so let's write down the 2 methods here for example 1. The first method we have is the list the factors method, which is what I had on the last slide. So if I told you find the greatest common factor of 28 and 42, with this method what you do is you list all the factors and you try to list them from least to greatest. So this is why having that factor rainbow helps. 1 and 28 make 28, 2 and 14 make 28, and so does 4 and 7. For 42, you do the same kind of thing with a rainbow. 1 and 42, 2 and 21, 3 and 14, 6 and 7. Now you're getting near the middle. There's nothing else that goes into 42. So then the last thing you do is you start to look for all the common factors of these 2 numbers. They both share a 1, they both share a 2, they both share a 7, and then they both share a 14. There's your winner, winner, chicken dinner. The largest number there becomes the greatest common factor. So I have this down as an example. All right, if this is a method that works well for you, great. But let's see if this next method also works. Try to find the one that you feel most comfortable with, Or challenge yourself to try both of them as we move through some of our practice ones. Here's the second method. And this is a method that uses prime factorization. I kind of like this method with really large numbers because it's a little easier to do when you're just looking at prime factors. So you're still looking for common factors, but if we broke down 18 into a factor tree, we would find that 2 times 3 times 3 gives you 18. For 30, 2 times 3 times 5 gives you 30, and for 24, 2 times 3 times 2 times 2. So what you do is you line up all the common prime factors that they have. They all share at least one 2. They all share at least one 3. Now, if you see for 18, you have a 3 here, okay? But there's no other 3 with the other numbers. They don't pair up, so you can't use that. There's 2 2's here, but no other number has a 2. So the only 2 numbers they share are 2 and 3. So to find the greatest common factor, just multiply all those prime factors together. And you'll find the largest number that 18, 30, and 24 have as a common factor is 6. So the GCF of these three is 6. Again, this is a different method you can use. Which one do you feel most comfortable with? That's what I'm going to want you to use. Or again, challenge yourself to try both as we get into our practice problems. All right, give a shot at finding the greatest common factor of 18 and 36 using one of the methods you feel most comfortable with. Come back when you're done and we'll see how you did. So I decided to display both methods for you to find 18 as being the greatest common factor. On the left in the blue, you can see I listed all the factors for 18 and 36, and I found the largest number they have in common is 18. In the red, I did a prime factorization tree, and I found 18 is 3 times 3 times 2, and 36 is 3 times 3 times 2 times 2. They all shared one set of 3's, two set of 3's, and one set of 2's. So 3 times 3 times 2 is 18. So that's how you can use one of the two methods. All right, try it one more time with 10, 20, and 30. See if you can find the greatest common factor. This time when you're finished, I'm just going to show you one of the methods when you are done. Good luck. All right, so I just used the list method. You can see I have gaps because I'm doing the rainbow method. And for 10, it's 1, 2, 5, and 10. For 20, it's 1, 2, 4, 5, 10, and 20. And for 30, it was 1, 2, 3, 5, 6, 10, 15, and 30. They all shared a 1, a 2, a 5, but the largest number they all shared was 10. So you should have gotten 10 for this one. All right, let's get into our second example for this lesson. And we're going to look at how problems that are problem solving can be applied or using greatest common factor. So here is a problem. It says Jenna has 16 red flowers and 24 yellow flowers. She wants to make bouquets with the same number of each color flower in each bouquet. So what's the greatest number of bouquets she can make? Well, basically, we have to find out what's the greatest common factor of 16 and 24. So now that we understand that, we can then make a plan. And based off our knowledge, we know that our plan is going to be to find the greatest common factor in one of two methods. So here, you can use 16 and 24 and try to find the greatest common factor. With this one, I'm going to use a prime factorization tree. What makes 16? That would be 2 times 8. 2 is a prime, but 8 can be broken down into 2 times 4. 2 is a prime, but 4 can be broken down into 2 times 2. So 16 is 2 times 2 times 2 times 2. What about 24? What can we break 24 down into? Well, the one that I'm thinking of is 2 times 12. 2 is prime, but 12 can be broken down into 2 times 6. 2 is prime. 6 can be broken down into 2 times 3. And now our factor tree is done there. So 24 is 2 times 2 times 2 times 3. So we can see that they both share a 2, a 2, and a 2. So they share 2 3's. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. And that is the greatest common factor that these two have. So basically, what is this telling us? It's telling us that the largest amount of bouquets that we can make would be 8 if you're going to use all the flowers evenly. So put this down as an example before moving on. Here's a similar one you try, but this one we're looking at Peter having oranges and pears. And he wants to make a fruit basket with the same number of fruits. So go ahead and find the greatest number of fruits, greatest common factor, that can be made with those two numbers. Come back when you are done. All right, so what you should have found, and I used the list method for this one, is that 9 is the largest number they have in common. So the total amount of baskets that Peter could make would be 9 baskets. Hope you got that right. In the home stretch here now, I want you to answer these 2 box of thought questions before moving on to the quiz. Explain what the greatest common factor of 2 prime numbers could be, and tell what the least common factor of a group of numbers would be. You may find both of those answers to be similar. And here is your long quiz of 5 questions. Find the greatest common factor of 4 different sets of numbers. You'll see 3 and 4 are both 3 numbers. A little more work. And then Mrs. Lovejoy is making a flower arrangement. She has 36 red carnations, 60 white carnations, and 72 pink. So what's the greatest number of arrangements that she can make? That's what's missing at the bottom. Hopefully you did well. Can't wait to see your work. We'll see you next time. Good